University campus meant to provide open and green spaces for students to create and excel. The campus outdoor space COS of the College of Engineering in Tanta is a central square overlooked by the college buildings, which exposed to excessive solar radiation without shaded seating areas or convenient passes. As a result, social contact and comfort environmental retrofitting were the main pillars of the design decision. The retrofitting process began with a general examination of the COS to determine main obstacles. After that, suggesting and analyzing appropriate solutions. Finally, comparing COS before and after implementation of the design elements and guidelines. The campus open space can be indicated by eight sides or an octagonal shape plaza. The total area of the plaza is almost 2,333 meters. The main COS in front of the building was designed almost like the Islamic mafruka shape, embracing greenery and pedestrian buses. The main target of the design was to protect COS users from excessive solar radiation and high temperature by setting up semi-arched buses surrounded by trees and shrubs and establishing shaded seating areas like pergola. Moreover, pedestrian buses were defined by different floor finishing materials. Wooden material and the Islamic design of seating were arranged on both sides of the entrance, in the middle of the seating areas in front of the main building entrance. Some occasional land use can be observed, such as exceptions and student center services. In the middle of the square, four wooden pergolas were added to create semi-closed social activity shaded areas. Also, two fountains were installed for noise depletion, reinforcing a stress-free atmosphere. Besides, its cooling effect decreasing surrounding temperature. As we see here, the vegetation and planting, cool materials, shading methods, water elements, and building heights variation. First, field measurements were appraised by Nova Linux Weather Station and investigating weather data files through the Climate Consultant Program. Investigations revealed excessive solar radiation and high temperature, hampering using overlooked spaces between buildings. The data was investigated on 21 September at 2 p.m. through the study period due to momentary weather changes. The selected COS was divided with 20 monitoring points distributing in grid distribution with grid different sizes. The result due to implementation design were showing a remarkable decrease in air temperature and radiated heat flux after design modification. The main advantage of using CFD is for swiftly predicting future design scenarios based on solid-based input data and analyzing the environmental performance of the implemented design. The five main methods of Ansys Fluent simulation begin with creating a geometrical model using available data and drawings. We used AutoCAD program in the current study to build a three-dimensional model. Secondly, the grid cell generation process. The third stage was focused on setting up the surrounding boundary conditions which identify the surrounding buildings, surface and needed measurement point. Fourthly, the iteration process using energy equation, radiation, Roseland model, solar radiation, solar loading, and the turbulence kinetic energy K epsilon method. According to ASHRAE Handbook 2005, people dressed in normal winter clothes. The confident temperature is 20 degrees Celsius to 23.3 Celsius at relative humidity 50%, which could be up in with lightweight clothes 2 degrees 0.8 Celsius. And ASHRAE also indicated if the global horizontal radiation value exceeded 315 watt per meter square, there is a need for shading devices. The result here shows before implementation and after implementation our design. Before implementation, the surface could be up to surface temperature could be up to 70 Celsius. After implementation, it decreased to 44 Celsius. Air temperature was 50 Celsius, decreased to 35 Celsius. Global horizontal radiation was 650 watt per meter square. It decreases to 150 watt per meter square. These results are important as they reveal the new methods to assess the retrofitting design of campus outer spaces, which took into consideration environmental conditions and surrounding boundaries. The obtained results also support retrofitting design decision, either in greenery or installing pergolas or use surface finishes material or water element installed. Monitoring the environmental performance of the COS by means of measurements or using simulation programs led to emergence of problems that hinder the use of COS spaces. The surface temperature was 70 degrees and the air up to 50 degrees, which was very difficult to go through buildings. We can see here this comparison of absorbed infrared solar flux, which decreases from 290 watt per meter square to 87 watt per meter square. Also, infrared solar flux reflected. It was 71 watt per meter square, decreased to 21 watt per meter square. Using the simulation program Ansys Fluent in evaluating the new design enable us to make a more profound analysis of many factors affecting the environmental performance. Contours of visible solar flux, it is decreased from 480 watt per meter square to 180 watt per meter square. Conclusion: the importance of the environmental approach in the proposed retrofit of the COS was authenticated through the assessment of the design decisions technically. This research specified a successful design strategies for campus outdoor spaces to achieve optimum use of space and to create a healthy, vibrant, and sustainable environment. Also, it represents technical ways of qualitative evaluation of the renovating proposals. Thank you, and forgive me for my hurry. It is because of the limited time which I don't want to exceed 10 minutes. Thank you very much.
Dr. Hurash, are you here to stop share screen?
Yes, I'm going to open the second authors. I would like to thank Dr. Shahira, Professor, and also Dr. Mustafa Elvan for such a great analytical study.
Dr. Hurash, I think I can open the sharing. Let me try because here there is nobody. Maybe my net is better now.
Perfect.
I will try and we will see if I could. 1 minute. It is
Thank you, Dr. Mustafa. I think I have a problem with my internet, but it is very interesting work for you and Dr. Shahira. We will talk about that later. Thank you.
Thank you very much.
Thank you very Dr. much. Mariam, can you share the next presentation?
Yes, I will share it now.
implementation of value engineering in Iraq as opportunities and obstacles.
Do you have the voice?
Case study.
Perfect.
In my
Thank
presentation,
you.
I will give a general overview.
My internet now
and
is better.
Literature review.
I also put the
Explain
CC
the
button.
methodology
Everyone will be
followed in this research, and the case study and the results obtained from it, and the references. As a background to understand the basic issue, which is the engineering management back there in Iraq. Generally, we have a poor engineering management, and that started from the planning phase to the implementation. For example, in the planning phase for the creative and the innovation limited level in the planning phase, and in the implementation by bad implementation, or either by the old or limited using of modern technologies. The second one is the lack of decision-making technique as a comprehensive decision-making technique that cover all the needed sides as a structural point of view, material point of view, even economic point of view. And number three, which is the repetitive projects. The majority of the projects are just repetitive. And I'm not talking about highway or something as a construction. I'm talking about building construction for two sides, the housing, residential, and the commercial or administrative or even educational buildings are just repetitive projects. And the other issue, which is the limited application. We have a quite high amount of research for many aspects in engineering management or other aspects of management and engineering in particular, but the application is very limited. Here are some examples for the repetitive projects. We can see both the residential and the commercial, administrative, and educational building. As a main objective of my research, I will try to examine value engineering as a tool of construction management in Iraq, whether it is applicable or not, and as a decision-making technique, a comprehensive one to see whether it's meet to the functions there for the users and for the engineering society. Number three, as a case study, an application approach by examine it and see the opportunities and obstacles. So as a literature review, we should understand the value engineering. Value engineering is a concept that deal mainly with the value of an alternative. For example, the highest value for an alternative comes with the best quality and meet our function to the lowest cost. And by understanding this relation between the function quality and cost on the phases, which is the value engineering phases, starting by gathering an information for the site, for the general situation, then the function analysis by the users or for the engineers. What are the functions to meet by giving the decision, even in the planning or after that in the implementation phase. Then the creative by giving the alternative and try to meet the function. And then the evaluation between these alternatives by using the value analysis and to try to make a development whether we can achieve a better alternative or not. If not, the best solution will have the presentation to the stakeholders. Here are some basic and traditional technologies in Iraq, and I'm talking here basically on the repetitive projects as a housing or as a educational, administrative, local buildings in Iraq. My methodology will be about giving a literature review first for the base information about construction management and value engineering, then give the needed information to implement the value analysis, and then suggest alternative to our case and evaluate them using value analysis to come up with the best solution.
Dr. Maria, the video is not moving.
Evaluate these results and giving the recommendations and to note the obstacles and the opportunities by implementing this strategy.
Excuse me, Abdullah.
Which is a 3 stories
do you hear me?
Yes, I hear you. I'm here with
Province. It was constructed 5 years earlier.
What is the problem with the video?
I think you opened another tab. This is another tab. Go back.
He's sharing another video.
Yes, exactly. You are sharing another one.
The feedback.
The previous one is opened. Above. It's above. You can see it above. No, close this one.
when the material
Stop
used is widely available
Open,
as RC.
yes, this one,
And the
up.
open system was
You can see
which
two
is
tabs of
modified
YouTube.
since there
Two
is
tabs of YouTube.
almost no
Yeah.
constant
Is it okay
function
now?
or
No,
buildings.
open
We
the previous
by
tab
time.
of YouTube.
Also,
There's
we
two
have
tabs.
some issues and disadvantages by bad
Shall I stop
Dr.
sharing?
Mariam, do you
for the building?
I stop
and
sharing?
please stop sharing to don't make the, yes. So is there another sharing of video?
No, share again now, please, I think.
I have to share again?
Yeah, you can share.
But there is another video is going now.
So
Not-
close,
not-
Doctor. Is there any other sharing of video? Maybe Dr. Horaksh?
Actually, no, I'm not sharing any. Just let me open the one. So I'm going to open Dr.
So,
Haji.
Dr. Mariam, please shut down your YouTube in order to listen to one only.
I'm going to open Dr. Salah Haji Ismail. Am I right?
No, wait.
Yes, I am here instead of him.
Yes. Yes. Exactly.
I can share instead if you like.
No, I want to be sure that
No,
the
no.
program that has been sent to all of them is correct. That or maybe Mariam selected the wrong one to share. That's why I'm trying to play it again to be sure that it is working. Then I will share my screen with you. So now I can see that again the same one came. Let's check with each other.
The implementation of value, yes.
This the implementation of value. So please check this one to be confirmed. Is it the same one, dear Abdullah Muhammad?
Yes, it is.
Everyone.
Yeah.
My professors, my
perfect,
colleagues, ladies and gentlemen,
It's perfect now.
My presentation. My name is Abdullah Muhammad Al-Hamdani, and I will explain the implementation of value engineering in Iraq as opportunities and obstacles on a case study. In my presentation, I will give a general overview and a basic literature review, and of course explain the methodology followed in this research, and the case study and the results obtained from it, and the references. As a background to understand the basic issue, which is the engineering management back there in Iraq. Generally, we have a poor engineering management, and that started from the planning phase to the implementation. For example, in the planning phase for the creative and the innovation limited level in the planning phase, and in the implementation by bad implementation, or either by the old or limited using of modern technologies. The second one is the lack of decision-making technique as a comprehensive decision-making technique that cover all the needed sides as a structural point of view, material point of view, even economic point of view. And number three, which is the repetitive projects. The majority of the projects are just repetitive. And I'm not talking about highway or something as a construction. I'm talking about building construction for two sides, the housing, residential, and the commercial or administrative or even educational buildings are just repetitive projects. And the other issue, which is the limited application. We have a quite high amount of research for many aspects in engineering management or other aspects of management and engineering in particular, but the application is very limited. Here are some examples for the repetitive projects. We can see both the residential and the commercial, administrative, and educational building. As a main objective of my research, I will try to examine value engineering as a tool of construction management in Iraq, whether it is applicable or not, and as a decision-making technique, a comprehensive one to see whether it's meet to the functions there for the users and for the engineering society. Number three, as a case study, an application approach by examine it and see the opportunities and obstacles. So as a literature review, we should understand the value engineering. value engineering is a concept that deal mainly with the value of an alternative. For example, the highest value for an alternative comes with the best quality and meet our function to the lowest cost. And by understanding this relation between the functional quality and cost on the phases, which is the value engineering phases, starting by gathering an information for the site, for the general situation, then the function analysis by the users or for the engineers. What are the functions to meet by giving the decision, even in the planning or after that in the implementation phase. Then the creative by giving the alternative and try to meet the function, and then the evaluation between these alternatives by using the value analysis and to try to make a development whether we can achieve a better alternative or not. If not, the best solution will have the presentation to the stakeholders. Here are some basic and traditional technologies in Iraq, and I'm talking here basically on the repetitive projects as a housing or as a educational, administrative, local buildings in Iraq. My methodology will be about giving a literature review first for the base information about construction management and value engineering, then give the needed information to implement the value analysis, and then suggest alternative to our case and evaluate them using value analysis to come up with the best solution, and then to evaluate these results and giving the recommendations and to note the obstacles and the opportunities by implementing this strategy. As a case study, I will define my project, the building that I used, which is a 3 stories educational building, a part of University of Fallujah in Al-Anbar province. It was constructed 5 years earlier, and the structural system used is the skeleton cast inside system. Starting firstly by asking the users and engineers enrolled there about the building and the whole situation, and to take the feedback. As advantages, we note that the architectural design was okay since it meets the purpose as educational building. Then the material used is widely available as a RC, and the skeleton system was okay, which is give us the ability to modify since there is almost no constant function for our buildings. We change it by time. Also, we have some issues as disadvantages by bad thermal and sound isolation, and also the bad implementation for the building and the wasting in time. So by understanding this issue and understand what are the problems to solve and what are the issues that we want to improve, we give up the criteria for our value analysis. Firstly, the enhancing for rigidity, then environment compatibility, repairing easily, modifying ability, thermal and sound isolation, code compatibility, and fast build. Also, we give our alternatives to the one that is already used as a steel structure, precast concrete, and a load-bearing walls. So starting by modeling and quantities for our alternatives that we suggest, and the alternative and the existed one, the structural system, by using Revit program and calculate the quantity for every structural element to give more accurate calculation. And that will be used in the cost analysis, of course, to see the price, the life cycle price for each alternative. This life cycle cost consider the surface life, and the surface life is taken in this study as a 50 years for educational building based on the European code, and the maintenance cost is a percentage from the initial cost as it's used to be in the Iraqi society. So value engineering, as we mentioned before, the best functional quality to the lowest cost. And a weighted evaluation was obtained by the help of 11 different engineers, experts in the field. And after analyze their feedbacks and to the cost that we obtained, we found that the best solution was the precast concrete, then the steel structure. As an evaluation approach for our results, we get back to the structural studies, and we found that the advantages of precast concrete facing the on-site concrete, that firstly it enhanced the rigidity, which was one of our criteria. by the experimental research by Nowak, for example. He found the mean strength and specified strength for the precast concrete is much higher. Number two, the time consuming by VS and also experimental study found that the precast concrete minimized the time by 35% for using the precast concrete. Number three, which is the cost decreasing by Touré and Wagner, they found that the payback period for precast concrete is 2.5 years. Whether it's for on-site, it's almost for 3.8 years. Based on Iraqi standards, they show that the precast concrete has a percentage of wasting only 2%, where the on-site concrete has almost 7% of its quantities as a wasted materials. Another issue, which is the reinforcement ratio. Based on the ACI standards, we found the precast concrete for both longitudinal and transverse reinforcement as a steel amount in the RC, in the concrete, it's less than the on-site concrete. Also, the transportation time will be less. As achievement and obstacles to this study, the achievements that we obtained the essential criteria for decision-making in such cases. Also, we found that the value engineering is an applicable strategy in Iraq, and we could obtain the better alternative to our case. Some obstacles were due to the cost estimation as a unit price issue and the old standards and the lack of information. To come up with a conclusion, and we recommend to train the engineering society, especially for value engineering, and to update the unit price by having a unit price standards monthly, annually, to give more accurate and to give a better decisions by the engineers. Also to update the standards, the structural standards, the engineering standards regarding the new system, the new technologies, and try to spread the precast culture in the society and have at least one company of precast concrete in each city. Try to obtain also and have the Iraqi branch, Iraqi Value Engineering Society for as a branch for any international society, and try to include the value engineering in the contracting process, in the contracting by adding some trophies, for example, for using it, or at least just teach people, notify them about the advantage of using value engineering. These were my references, and I will be glad to hear your comments and answer your questions, if any. Thank you a lot.
Thank you, Mr. Abdullah. It is very, very important issue. We will talk later about it, especially in countries like Iraq and developing countries, low developing countries. The next will be minimize the carbon footprint by using round earth technique.
I'm going to, maybe Dr. Mariam would like to share.
I will share now.
Also, our other presenter, Mr. Mohammed Emin Shishman, I think they don't have presentations, so we will have enough time, hopefully, to be on time for the next roundtable.
Know that the climate change affects hardly all around the world, causes several natural disasters, and maybe sometimes lead to
Is it okay?
Unfortunately, the result of that to destroy our city. And after that, we really think about how we can reconstruct our city. And the reconstruction process
is it
itself,
okay?
It's more difficult than the normal construction because we need to deal with the rubble, we need to deal with the waste. And the construction sector itself has consumed a lot of energy in different stage. First one, when we need to produce a material, we need to consume a lot of energy. After that, we think about the transportation, transit this material from the producer to the consumer. The other things is it's the construction process itself. After that, we need to think about the life cycle of our building because we need to consume energy. As a result, the construction sector caused more than 20% of carbon dioxide. So I start ask how we can minimize the carbon footprint in reconstruction process. I found that we need to deal with material. Material, it has a major impact. We need to find sustainable environmental material, which don't need a lot of energy and don't produce high of carbon dioxide. Another things about the technique which we need to use during the construction process and thinking about the consumption of energy after the building finish. So my solution, it was using rammed earth. What is the rammed earth? Rammed earth is a technology for construction foundation, floors, and wall using natural materials such as soil, chalk, silt, lime, or grass. In rammed earth, we are concerned about some material like gravel, sand, silt, and clay, which is inside the soil. There are two mechanisms make rammed earth hold together. We are looked about two features in the soil itself. The first one is the boundary between the material. The second one is the clay. There are some features we need to look at between the boundary between the material, the volume of the material, and the quality of the clay. Not all the soil can be used in the rammed earth. For this reason, we have two types of rammed earth: unstabilized and stabilized rammed earth. The first one, it's use raw material, just soil, without adding any blending material. The second one, which is stabilized, we need to add some blending material like cement. To determine that, we need to make some simple tests, and sometimes we need to make some controlled tests. This test help us to define if the soil need to adding some blending material or not. For this reason, I start to look about some research about different type of soil. And I found a study in San Luis Obispo, which used three different type of soil, which is clay sand, dark yellow brown, and sandy clay. This type of soil needed to add some cement. It's about 7%. And the result, as I mentioned, it's not acceptable for all the soil. Some of them, it's get required code, another it doesn't. After that, I start asking myself, can we use another material? Can we add organic material in stabilized or unstabilized rammed earth? And I find the study talk about that. They made different mixture with adding cement and without adding cement, stabilized and unstabilized. And sometimes they use organic material like dung. And the result from this mixture, the best one is the A, which use it stabilized rammed earth with adding some cement. Another thing or another concern in my study was about the rubble. Can we use the rubble in reconstruction process? Actually, we can use the rubble, but we need to design our soil by ourselves, because when we use the normal soil with the rubble, we don't get a high result. But when we use with the designed soil, which we are call it energetic soil, the result is acceptable. After that, I start asking about the waste. Can we use the plastic waste in this process? Actually, yes, we can use it, and it gets a high result than the normal soil or than adding the cement itself. We can using the fiber, and it will get us a high result. So when we look about the rammed earth, actually we look about the thermal behavior of this building. And I want to make comparison between the rammed earth itself and between the concrete building. And we found that the rammed earth is better than concrete building, according to the study which made in Morocco. And I found that rammed earth doesn't lose height, and it's better than the concrete building according to the design. And there's some factor going inside this study, but we are focused just about the material, and we found it's better than concrete. Another thing we are start asking ourselves, can we use the isolated material with rammed earth? I found a study talk about the normal rammed earth without isolated material and other without with isolated material. And I found, yes, we can use it, and sometimes we have to use it in some condition. So my conclusion of this study, we can reduce carbon emission in reconstruction stage, and we can use rubble and waste material in reconstruction process. And sometimes we need to think about the isolated material in rammed earth itself. Actually, it's better than concrete, but sometimes we need to add isolated material. Thank you for listening.
Thank you very much.
Dr. Mariam is, we are waiting for her to.
Dr. Mariam, if it is possible to.
I think they share the sessions, the last author of this session, which is supposed to present the research on multi-story timber building in the construction industry.
It's not available here?
No, they are not available, so you can conclude the session there. Sana.
Okay, thank you very much, Dr. Horash. If there is any questions, please, the floor is yours, all audience and authors. If they have, and if there is any questions regarding the three previous papers, you can raise your hand if you have any questions. If personally I have some questions, if there is no any questions, I will start to ask. Any questions? Okay, I will start with the first with Dr. Mustafa. Dr. Mustafa is here?
Yes, sir. Yes.
Dr. Mustafa, it is very interesting work that you did. I want to ask you, okay, I appreciate 100% what you did, and it is a professional work with very good results, as we see, 650 become 150 irradiation, I think. But I want to ask you your personal opinion. How much we can trust simulation programs? As an architect, we have to involve some, let us say, human feeling in our work. So how much you can trust simulation program, despite the good results that it is giving you? This is only the question I'd like to reflect.
Okay, sir. First, I want to say some points. There are too many simulation programs, which varies from accuracy. Ansys Fluent, I think it is not for architect. It is something professional branches of engineering. Like if we can say when he calculate natural ventilation, it is not that easy that design builder could he uses the mathematics and equations in this field, which you can choose like epsilon or linear or laminar or which is very sophisticated to an architect, which I had difficult in the beginning. Ansys as a program special is the most, I think, is the most accurate simulation used in other branches than architect. But as you said, sir, I am not using simulation to figure out a precision value. I am looking for the direction of this result. I mean, this simulation is only just a second. It's a stationary reveal. 1 second in the whole year, but it shows a high decrease. This is I am looking for. Also, there are something I can't do without this simulation. Like he can split several kind of radiation, like infrared, or he can split visible electromagnetic waves than not. So I use it to analyze and detect, and I am going into to the right direction. So that we used a Nova Linux weather station to validate or to be sure that this is the right reflect on this design or retrofit. Sorry if I long.
No, it is very clear. What I was thinking, if we can mix let us say this is objective way of study. If we could mix the objective way with the subjective way, opinion of the people or the feeling of the people, maybe we can get better results. Do you think that?
I want to say some kind of measurement, like the opinion, or like when we measure or indicate thermal comfort by fungus index. I don't depend on this because sorry if I said I am fat and I don't feel cold so much. I don't feel cold so much. When I am very, very satisfied with weather, some people say they are freezing. So I went to the.
So you will not be the one that should be asked.
Yes, I am. I have a very far answer or very excessive answer. So I went to the ASHRAE. ASHRAE say 315 watt per meter square. Okay, this is the reference I will take. Also, I think we can add this objective of people to figure out what is happening. Could be. But I have a question for you, sir. If the two methods get the same answer, what should we do?
Two methods, the same two methods get the same answer means, what do you mean by that? You mean
means if I asked people, they said no, it is not okay, and the physical measurement says it is okay. What should we do then?
I believe there is. I don't think the result will come in such way that people says no and the measurements say yes, but for sure there is some harmony or distance between both of them. You can test this distance in order to make like correlation between them and do this correlation like a standard for yourself in order to measure again the condition and to see the result is correct or not, it's valid or not valid. This is what I think. I don't think there is radical answer between both, unless you ask somebody like yourself about the thermal comfort.
I think I should focus on some picture which indicate in this area there is no one can afford to stand, and after that busy area and very had too many occupant of student. Okay. Yes, sir. I think I could focus on this.
Thank you.
Thank you, sir.
Thank you, Dr. Mustafa. Thank you very much. If Abdullah is here, I want to ask him something also. I reflect on his important presentation. Abdullah, are you here?
Yes, I'm with you.
Thank you very much for your presentation. We know all the value engineering is very important, especially for engineers, and in the countries that are witnessing construction blooms like Iraq, for example. But the problem is the obstacles everywhere is, we can say there is a standard obstacles that you mentioned them. This could be everywhere, but in Iraq, I think there are different type of obstacles. For example, in Iraq, the budget means the project should fit the budget, not the budget fit the project. Do you understand what I mean? Exactly. For example, in your governorate, Ambar, for example, they are they have budget for, let us say, $2 billion. They are asking the authorities to make projects with this money. They are not asking them oppositely. I think this is one of the problems about the value engineering in Iraq. What do you think?
You are totally true. This is one of the main aspects. Generally, the limit should be something, let's say, from engineering perspective. For example, I want it, for example, to be has a capacity. If you are talking about educational building, a capacity of that much rooms, a capacity of that much students, etc. These should be the limits where I come.
This is the planning. What I want to tell in the end of the day, it's a planning, a lack of a planning for the project. And I agree with you 100% for the precast concrete, because it is also eco-friendly and environmental solution. I hope to see this kind of project in Iraq.
We all hope, but the issue is there is no time for creative time in the planning. Yeah, you know that.
Let us to be optimistic.
You know that. Thank you.
Be optimistic. Thank you very much.
I hope. Thank you too.
Very much.
Thank you. It's my pleasure.
The last Ramid Earth. Ramid Earth is.
Yes, Professor. Actually, I'm here.
You are here? Okay,
yes.
Thank you very much. For sure, Ramid Earth construction, it's very important for the environment and cutting the carbon footprint, because you are reducing the cement the cement content in the construction And I think you are using 5% as far as I understand this, right?
Yes. Actually, it's dependent on the type of the soil and the quality of the clay.
Yes, exactly. This experience, I saw this type of construction in India. They have this type of technique, and but the point is, I want to ask you if we use this in rainy and humid places. What about the erosion? Do you know the durability of this kind of rammed earth?
Yes, actually, in the, as you mentioned, in the rainy places, we need to build the foundation in concrete. We need to deal with another solution like the stone and something like that. Not every
means hybrid.
Yeah, as you said. Not everywhere we can just use this rammed earth without using another type of foundation. It's dependent on the climate.
Yes.
It's dependent on the place.
That's great. Thank you very much.
Thank you, Professor.
Thank you very much. Dr. Huraksh, if you are, we
yes,
can
go. I'm around. We shall continue if Dr. Mariam may take the
let us to start with a comparative study on the responsive facade system. It is very interesting subject. Can we start?
Of course.
Yes.
Dr. Mariam, are you?
Yes, I will share it now.
Thank you very much.
As all we know, the life has been changing.
Is it okay?
Depending on constantly changing.
Now?
Which affects including architecture.
Yes.
As the activities of movement society transforms, the concept of movement has become a part of architectural design. Since the existing buildings or building components cannot respond to the changing needs, the design process of the buildings has been started to be questioned. New solutions have been sought even in the facade design in order to adapt to the change using the concept of movement. When the existing literature on the responsive facades has been investigated, it has been seen that the facade systems are generally reviewed based on their system types or materials. There is a lack of clear definition in element types, movements, and control systems. In this study, the aim is to propose a new comparison matrix to review and analyze the existing examples of the responsive facade. A comparison matrix has been created based on the movement of the responsive facade systems, since the movement is the main parameter which can be used to identify the different facade systems. 5 movements have been defined in the comparison matrix. In addition, there are 6 other parameters in the matrix, which are the type of system, the type of control system, the control type of elements, the function of the facade, the response time of the elements in the system, and also visibility of the facade system. Type of system indicates whether the system is active or passive. Type of movement defines the motion of the elements in the responsive facade systems. The movement type have been examined under 5 main headings: rotation, deforming, folding, sliding, and hybrid. Type of control system indicates the factor that provides the movement of the system. The responsive facades have been classified into 2 systems, as hand-operated control or central control. For control type of the elements, unlike the previous category, the focus is on the control of the elements to investigate whether the elements in the system can move individually or not. Function of the facade. In this category, the functional purpose of the facade system has been defined, such as daylight control, thermal control, or airflow. The response time refers to the time required for the facade elements in the responsive facade system to perform their actions. The facade and its elements affect not only the outer appearance of the building, but also the interior. 23 facade applications selected within the scope of the study were converted into a table according to the determined matrix. Thus, comparisons and examinations were easily completed with the help of this table. Among those 18 active systems, the facade systems that have folding movement are the Kiefer Technique Showroom, the Al Bahar Towers, the Open Cafe Restaurant, and also Wood Culture Museum. Having hexagonal panels and linear actuators, the responsive facades of the Al Bahar Towers are controlled by Central Building Management System. The system operates in real time and mainly provides daylight and thermal control. In the Kiefer Technique showroom consists of folding panels that are controlled by engines. The facade system serves the daylight and thermal control as the previous example. On the other hand, the open cafe restaurant has a glazed facade on which each element can move independently by means of a motor. It allows cross ventilation when the windows are folded. The panels on the facade of the Wood Culture Museum consist of a hexagonal leaves connected in pairs on a black metal profile. An engine controls the movement of the leaves that perform a folding movement in minutes. The main function of the facade is the daylight control. While the visibility is high in Kiefer Technique showroom and also Open Cafe restaurant, it's at medium level in the Albahar Towers, since the frames of the hexagonal modules somehow block the view, even in fully opened configuration. It's at low level in the Wood Culture Museum. There are 8 facade systems examined in the rotational movement category. Composed of stainless steel feather-like elements, the facade of the ThyssenKrupp headquarters changes its shape according to the movement of the sun throughout the day. Completing its movement in seconds, this facade system not only provides a regulation of the light entering the interior, but also prevents unwanted solar heat gains. Likewise, the facade elements of the several headquarters are made of metal panels that can be opened independently. Each panel makes a rotational movement around the vertical axis placed on the long edge of the elements. The main purpose of using these elements are to protect the structure from overheating and to reduce cooling load of the building. In both examples, the visibility is at the medium level. On the other hand, there are also other examples which the visibility level is high. In the Pavilion 2014, the panel metal elements on the facade move independently, which can be opened or closed to create different configurations. The panels can be opened in few minutes up to 90 degrees with the help of the hinge located on the short sides. In the other example, Biomimicry, the facade elements are multifunctional in such a way that they create new spaces for the users when unfolded and serve as shading roof elements. The facade has been formed by rounded triangular-shaped panels that are placed horizontally and vertically. While the vertical panels can provide privacy, the horizontal panels not only serve for shading purposes but also became balconies. Controlled by hydraulic cylinders, the facade elements provide thermal and daylight controls. The west facade of the Council House 2 building is covered with blinds made of recycled wood. It was built to protect the offices from the sun in the afternoon and to utilize the daylight as much as possible when the sun is in east direction. The west facade of the Council House 2 building is covered with blinds made of recycled wood. It was built to protect the offices from the sun in the afternoon and to utilize the daylight as much as possible when the sun is in east direction. Composed of a large pivoting window, the facade of the Chicken Point cabin building has a movable system that maximizes the user's visibility as opening the main living space to the landscape. In another example, Dancing Pavilion, there are round mirror elements that make full rotation in horizontal direction. There are sensors inside of the building which capture the music and the movement of the dancing people. Since the building was constructed for a temporary usage, there is no functional objective of the facade like thermal control or daylight control as the previous system. The Livraria da Villa is a bookstore in Brazil. 5 rotating bookcases are located on the main facade, which are attached to the floor and ceiling along the middle axis to create spatial entrance and provide the airflow. The other type of movement presented in the comparison matrix is sliding movement. The facade of the California Gallery is similar to the design of the Chicken Point cabin building. It can open in seconds and the system allows natural airflow as creating a main entrance. Another example of the category is a restaurant in London. The building has a retractable curved glass facade that enables not only to open the main space to the public but also to ventilate the space naturally throughout the year. Although there are many realized examples of the responsive facade having folding, rotating, or sliding moments, the examples of deforming category are limited. The One Ocean Pavilion Expo in 2012 is one of the examples of deforming category. The facade elements are flexible lamels that move according to the daylight. As the lamels move one by one on the structure, they can create different patterns on the facade. The other systems in the deforming category are based on smart material. Unlike the previous example, the homostatic facade system is a passive system that regulates itself according to the environmental factors such as daylight and temperature. Apart from the previous examples, there is also a facade system that has hybrid movements such as rotation and translation. Inspired from the Islamic pattern Mashrabiya, the Institute de Monde Arab Saud facade consists of camera-like diaphragms. The diaphragms open at low altitude levels while they close in opposite direction when the sun shines brighter. The expansion and contraction mechanism of these diaphragms are regulated by the sliders to automatically control the amount of light entering the building. Apart from the active systems, there are also passive facade systems which can move without requiring an actuator, motor, or sensor. 6 samples have been examined in the passive responsive system category, which designed as a second facade skin in the Pittsburgh Children's Museum. The facade elements move slightly with wind pressure without the need of energy or additional support. These elements, which create a light and bright effect on the facade, are located on the aluminum facade frame structure. Likewise, the facade of the wind arbor has same design principles and goals as in the first example, but the elements are positioned on a thin cable net. In this example, consisting of aluminum fins, the system covering the glass facade of the hotel lobby shades the interior, blocks the sunlight and heat entering the building. On the other hand, the panels positioned in the breadbox pavilion are reflective modules that strengthen the wave effect as reflecting the sea based on the light during the day. Having similar movement behaviors in the elements, the Latvia pavilion composed of colored and transparent plastic elements that are positioned to represent the nature. The south facade of the museum consists of wind indicators and brown panels that are free to move independently according to the wind and remain at their initial configurations when there is no wind. All the aforementioned facade elements sway in wind and move independently. Various configurations can be seen on the facade in a short time. In this paper, as a systematic review has been conducted for the responsive facade systems using the proposed comparison matrix. Based on the matrix, it can be said that most of the applied examples of the responsive facades have active systems. Passive ones are usually used for pavilion or exhibition structures. Among the 23 examples of the responsive facades, only 3 of them are based on hand operation, whereas the rest of them controlled centrally. 12 of the systems complete their movements in seconds and 11 of them in minutes. Since the responsive facade systems are generally composed of modules that have capability of moving individually, the elements in such systems are free to move. That means each can be controlled separately. The elements in the reviewed 18 examples have this capability. When the types of movement are examined, it's seen that 14 of the responsive movement and 1 has hybrid movement. On the other hand, the rates are the low, medium, and high visibility categories are almost equal. It can be said that this study provides a simple and understandable guide to examine and analyze the facade system. And also, these are our references that we used for our study. And thank you for your attention.
Thank you very much.
We shall continue with the second biometric approach for adaptive buildings. Dr. Mariam, if you would share it, and it would also...
Yes. Yes, doctor. Now I will share the
next presentation.
Yes, please. And also considering the quality and speed of your internet, you can decrease the quality of YouTube video by the time that you are playing, so it will not affect the sound. It seems that in our previous presentation there was a little bit problem.
Participant in this conference. And
is it okay?
Yes.
Also, I would like to thank all.
Yes, it is okay.
It's okay.
My name is Riham Nadi Faragallah. I'm an associate professor at the Department of Architectural Engineering, Faculty of Engineering, Faros University in Alexandria, Egypt. My research paper is talking about biomimetic approaches for adaptive building envelope, applications and design considerations. At the beginning, I would like to introduce the topic that in the past decade, the evolution of biomimicry architecture was considered as an important issue for achieving adaptation strategies and principles to cope with different climatic aspects and provide thermal comfort. Building envelope is recognized as a key factor that affects the energy consumption of a building through design variables and inputs provided by the context. Thus, there is a growing concern to enhance energy performance and promote indoor thermal comfort through new concepts, materials, and technologies which encourage the design for adaptive building envelopes. The research will be discussed into three parts. The first part is the literature review, which deals with the concepts, terms, dimensions, levels of biomimicry, and adaptable building envelopes. The second part is the analysis of applications, which deals with biomimetic applications on adaptive building envelopes, especially or particularly in hot, arid climates. The third part is the proposed biomimicry design matrix for adaptive building envelopes, which concludes the design considerations and strategies for adaptive building envelopes to be adopted in hot climate regions. The main problem in the paper is that the current existing buildings in the Egyptian context have weak building envelopes, which are inefficiently sealed, making them exposed to heat loss and heat gain. There are several goals or objectives for the paper, such as presenting theoretical fundamentals about the significance of biomimicry, its approaches and levels, discussing the development of building envelopes and exploring its design measures and considerations, analyzing different biomimicry applications through adaptive building envelopes in several terms, such as heat, air, water, light, building materials, and so on, proposing a design matrix for adaptive building envelopes that could be adopted by architects and designers, especially in hot, arid climates. At the beginning, we need to have an overview about the concept of biomimicry. The term biomimicry comes from the Greek word bio, which means life or nature, and mimesis, which means imitation or imitating nature. Nature has a large database of adaptation approaches that can be used in the design process in general and in the design of building envelopes in particular. There are several scientists and biologists who have given different descriptions and different definitions for biomimicry, such as Benios in 1998, Guber 2005, Pedersen 2007, Scott and Var 2012, Lippold 2019. And from these definitions, it was observed that first, it was considered as a mere study of nature's ideas and imitating its design and process to solve a problem. Then it became an important feature and technique in the design. And lately, biomimicry became a creative, sustainable solution for environmental problems using innovative design strategies. Biomimicry has two main approaches, the direct approach or design to biology, and the indirect approach, which is biology to design. In the direct approach, biology, design to biology, there is total mimicry, partial mimicry, mechanics of context, and function physics, which tries to imitate the organisms, its behavior and ecosystem. This was achieved in Daimler-Chrysler bionic car, which was imitating the fish box. The indirect approach, biology to design, there is abstraction and inspiration, but on the organism level only, such as lotus flower that emerges from the swampy waters, which gave influence after that for self-cleaning materials. There are also 5 additional biomimicry measurements, such as the form of the building, the building materials, the construction, the process, and the function. Building envelope and its adaptation in nature. Buildings have developed from simple shelters to complex structures that adapt to their surroundings to raise comfort and quality of life. Also here, there are several definitions for building envelopes, like Rankuhi, who described building envelope as the boundary from which buildings communicate with the environment, or Hooven, who defined building envelope as a shell or a fabric or a skin of the structure or the barrier between the interior and the exterior of the building. There are three means of adaptations: physiological or functional, which relates to the organism's chemical process; morphological or structural, which relates to an organism's shape, size, pattern, or structure; behavioral adaptation, which relates to how an organism acts. Applications of biomimicry on building envelope. The first application is East Gate Center in Zimbabwe. It is a mid-rise shopping center and office block. It was designed to cool itself by natural means that was inspired by self-cooling mounds of the African termites. And to keep the temperature mild, heat gain was reduced using thick walls, building mass, limiting glazing, and deep overhangs. The second application is Al-Bahr Tower, Abu Dhabi. It presents the cultural elements of Abu Dhabi to provide comfortable spaces in harsh temperatures. Double skin and intelligent automatic shading systems were allowed for adaptability and flexibility in response to changing solar altitude angles during the day. The third application is the Ministry of Municipal Affairs and Agriculture office in Qatar, which has been designed with energy efficiency and sunshades on the windows that can be open and closed depending on the weather and mimicking the behavior of a cactus. The fourth application is the Council House 2 in Melbourne. The building is inspired by the bark of a tree based on linking the structure to its surrounding environment and living organisms. The use of biomimicry is evident throughout the building because the west facade resembles the epidermis of a tree that would moderate the external climate, while the north and south facades were influenced by the branching of a tree. After analyzing the four examples or the four applications from the design concept and how they were inspired from nature, their approaches, and it was observed that all of them were designed to biology, adopted design to biology approach. The level, if it's mimicking organism or the behavior of the organism or an ecosystem. Also, there was a comparison in the sub-approach in terms of form, material, construction, process, function, and the design consideration concerning heat, air, lighting, water, materials, and visual comfort, which led to establishing a biomimicry design matrix for building envelopes that was divided into three phases or three stages. The first stage is the problem, dealing with the challenges, objectives, and goals and limitations of the design problem. The second stage is the nature, the function, what does nature do and its process, how it is carried out. And finally, the third stage is the solution, which is the main stage. Through design looking to biology, it adapted 6 morphological features and its design considerations, such as heat, and how to provide thermal comfort and reduce energy demand through building form, orientation, massive walls, passive cooling; air, by supplying air and natural ventilation and improving indoor air quality through adaptable windows and cross ventilation; water conservation through grey water recycling, reuse of rainwater, light, like controlling solar radiation through balanced illumination, and this could be achieved through orientation of windows, type of glazing, deep overhangs, and adaptable sunshades. Visual comfort, enhancing visual comfort of the exterior of the building through the form, the concept, and the suitable openings, and also building materials, promoting thermal comfort and quality of space through local building materials found inside and materials that reflect solar radiation. All these physical features and design considerations could be adopted in the design of building envelope to achieve a sustainable built environment in hot arid climates. Conclusion and future directions. The research tries to encourage the use of biomimicry in the design envelopes. Biomimicry has proven to be an eco-friendly method for creating energy-efficient building envelopes through problem-solving techniques. Also, the research has analyzed different applications with different adaptation methods in hot climates. It concluded a biomimetic design matrix for adaptive building envelopes that could be used by designers in the design process of buildings, especially in hot, arid climates. The matrix suggested to define the human needs and environmental problems, stating goals, objectives, limitations, and constraints. It deals with nature through the function and process and how they are applied and carried out. It concentrates on 6 morphological features with their solutions, such as heat, air, water, light, visual comfort, and building materials. After applying all these previous adaptive physical characteristics of living organisms, and taking into consideration the design of building envelope, this may save materials, energy, achieve more functional, sustainable solutions, lower costs, and increase performance and durability. And also, it will serve as a tool to achieve a sustainable built envelope to develop the innovation engine in the Egyptian context. Thanks for your attention.
Thank you very much. Thank you very much, Dr. Reham. The last paper, it's the evaluation of the effect of mass housing facades on comfort condition, the example of Atakoi. Dr. Mariam?
Yes, now I am sharing.
Can you share?
Yes, yes.
Thank you.
Migration from rural areas to cities has been increasing with increasing population, increased machine use in agriculture and industrialization. These effects increase in urban population. Housing problems caused by increasing internal migration and fast urbanization, and it has been attempted to be solved with different.
I think there is a small noise in the video. Am I right, dear Salah?
Housing projects.
Unfortunately, I am not hearing the
noise,
the YouTube's very well because of the interruption of my.
The last one, if you don't mind, Dr. Mariam, you stop sharing. I will share from here to be in safe side.
Yes,
yes, it will be much better.
Okay.
With the high quality.
So, Dr. Mariam, please stop sharing.
I stopped the sharing.
Perfect, thank you. Let me share with you. Second. Perfect. We go with the last one, which should be the high quality.
Hello everyone, I'm Seda Yüksel Dicle, and today I'm going to talk about assessment of the effects of mass housing facades on interior comfort conditions based on the example of Ataköy. Migration from rural areas to cities has been increasing with increasing population, increased machine use in agriculture and industrialization. These effects increase in urban population. Housing problems caused by increasing internal migration and fast urbanization, and it have been attempted to be solved with different housing policies in different periods. One of these solutions is mass housing projects, which refer to a high number of residential building production in a shorter time and with less investment. Houses are space in which occupants spend long hours and expect to have the right comfort conditions, thermal, visual, and acoustic. Environmental and economic problems as a result of increased fossil fuel consumption, limited energy resource, and negative effects of increasing environmental noises underlines the importance of architectural design decisions. And these decisions for mass housing became more important than single houses. Fast population growth, advancing technologies, changing consumption habits with urbanization and industrialization increase energy demand worldwide. Regarding the distribution of energy consumption among industries, residential buildings have a major share in the total energy consumption. In Turkey, residential buildings are responsible for 40% of total energy consumption, and a majority of the energy is consumed by heating and cooling systems to achieve thermal comfort conditions. Another important environmental problem as a result of increased urban population and intense urbanization today is noise. Control of noise is getting more important with increased number of noise sources. Residential areas are exposed increasingly more to environmental noises as a result of fast urbanization and industrialization. Increasing energy consumption, limited energy resource, the damage of their use of the environment, and negative effects of environmental noises on people increase the importance of architectural design decisions. Building facades are one of the most effective design decisions. It controls outdoor environment conditions and affect energy consumption caused by heat losses and gains, and noise reduction value for outdoor environmental noise. Within the scope of this study, mass housing settlements that build in the same region in Turkey in different periods and have different facade systems and materials are evaluated in terms of their thermal and acoustic performance, also the amount of energy they consume to provide thermal comfort conditions. For thermal comfort, operative temperature and solar gains of the units and energy loss were calculated. And for acoustic comfort, noise reduction values of building facades of the units were calculated. Design Builder and KS simulation programs were used in study. Design Builder was used in the thermal performance calculation, and KS was used to calculate noise reduction values of the facades. The placement of the blocks was shown in figure 2, and residential buildings included in this study are in Ataköy region in Istanbul. It has temperate, humid climate conditions. Phase 1 D block were built in 1950. Phase 5 were built in 1980s. In both blocks have similar orientation and outdoor noise levels. Buildings in the phases 1 and 5 different building form. In order to compare energy loss of the buildings, energy loss were calculated for per square meter. In the study, the living room and bedroom volumes where comfort conditions are more important were selected. Building envelope properties are shown in chart 1, and blocks have different facade systems. Block D in phase 1 has brick facades, and block A in phase 5 has concrete facades. And transparency ratio of buildings are shown in chart 2. For thermal comfort conditions in study, operative temperature and solar radiation gains in units were calculated for January and July 21st. In energy consumption calculation, Indoor comfort temperature was set at 20 Celsius degree for heating period and 26 Celsius degree for the cooling period in the residential buildings. For acoustic comfort conditions, noise map were used for outdoor noise level, and the level of noise that the building facades were exposed was set at 70 decibel. Regulation and protection of buildings from noise were used for facade noise reduction, the limit values, and noise maps of the region are shown in figure. In study, building envelope details, which change depending on the construction year of the buildings, were comparatively assessed. Information on the living room and bedroom units are shown in the figure, and in study, calculation results for buildings are evaluated in separate tables for living room and bedroom units. When the study results are assessed, thermal comfort for living room units, daily average operative temperature and overall solar radiation gain values in living room on January-July 21st were higher in Block D than Block A. The difference between minimum and maximum values of daily average operative temperatures was higher in Block D than Block A due to the increased building transparency ratio. While heating loads were lower and cooling loads were higher in Block D, which was built in 1950, than Block A, which was built in 1980, due to the solar radiation gain and thermal mass. Cooling loads were higher. None of the buildings meet the minimum requirements for total heat transfer coefficient recommended by the standard. Under these conditions, annual overall energy load was higher in Block A than Block D, and there was a 35% increase in overall energy load consumption. When acoustical comfort for living room units, noise reduction value of the opaque component was higher in Block A due to the building's facade properties, mass of the structural element, and the presence of airspace between it. The noise reduction value of the composite envelope was higher in Block A with lower transparency ratio and higher opaque components. The noise reduction value of facade was higher in Block A due to the noise reduction values of the opaque component and transparent component ratio, and although they were built before the regulation, the buildings were found to meet the minimum acoustic performance class D requirements. When the thermal comfort for bedroom units, daily average operative temperature and overall solar radiation gain values in bedroom on January and July were higher in Block D than Block A. The difference between minimum and maximum values of daily average operative temperatures January and July was higher in Block D than Block A due to the increased building transparency ratio. While heating loads were lower and cooling loads were higher in Block D, which was built in 1950s, than Block A, which was built in 1980s, due to the solar radiation gain, none of the buildings meet the minimum requirements for total heat transfer coefficient recommended by the standard. Under these conditions, annual overall energy loads was higher in Block A than Block D, and there was 22 increase in overall energy load consumption. When the acoustical comfort for bedroom units, noise reduction value of the opaque components was higher in Block A due to the building's facade properties, mass of the structural element, and presence of airspace between it. The noise reduction values of the composite envelope, which includes both opaque and transparent components, was higher in Block A with lower transparency ratio and higher opaque components. The noise reduction value of facade was higher in Block A due to the opaque component and transparent component ratio. Blocks built before the regulation were not found to meet the minimum acoustic performance class requirements, and they provide the E acoustic performance class. Regarding the thermal performance and energy consumption, buildings didn't meet the limit values determined by the thermal insulation regulation. The transparency ratio in Block D and Block A, which were built before 1980s, had an effect on solar radiation gains and therefore on overall energy loss. Due to the increase in the ratio of transparent components on building facades in the living room oriented to south, heating loads decrease and cooling loads increase. Based on the simulation results, Block D compared to Block A for living room, 99% increase in heating loads, 219% decrease in cooling loads, and 34% decrease in overall energy loads. Block D compared to Block A for bedroom, 54% increase in heating loads, 183% decrease in cooling loads, and 22% decrease in overall energy loads. Change in the facade systems and transparent component ratio between blocks don't meet the requirements of standards had more effect on cooling loads. Regarding operative temperature values, the value which is closest to comfort temperature value set for January 21st, was achieved in Block D, and the value which is the closest to comfort temperature set for July 21st was achieved in Block A. In this case, less energy was consumed for heating systems in Block D and for cooling system in Block A, in which values closest to the required comfort temperature were achieved. According to the acoustic performance assessments, noise reduction value of the opaque components was higher in Block A due to the mass and material properties of the building facades. Regarding the composite envelope, because of transparent component properties were the same, noise reduction value changed depending on the noise reduction of the opaque component and transparent components. Despite high outdoor noise, the buildings that were built before the regulation on protection of building from noise became effective in 2017, meet the requirements of minimum acoustic performance class for a living room in existing buildings. However, facade properties were insufficient for bedrooms, which have a high sensitivity to noise. And this study found that decisions about materials, layering and transparency ratio for the facades of mass housing buildings built with different facade systems in the same district had an impact on thermal and acoustic comfort conditions and energy consumption. Design decision in mass housing systems in which many residential buildings are built simultaneously have more important role than they have for single buildings construction. In the new housing project, mass housing buildings are manufactured in accordance with current laws and regulation, and that will provide comfort conditions with minimum energy. However, the necessary measures should be taken in all the mass housing buildings, which are numerous today and cannot meet the requirements of today's regulation. And these are references, and thank you for listening.
Thank you very much. Thank you very much. Dr. Uraksh.
Thank you.
Should I leave the platform for you for the last presentation, or what do you think?
Yes, if you want to.
Sayın Rektörüm, ekranları başında bizleri izleyen Ege Üniversitesi ailesi.
Yes, sorry. If you want to conclude the first two, then I also conclude officially the conference to close. If you want.
Yes. First, let us to see if there is any question. There are any questions regarding the wonderful presentations. I
have question
in love with envelopes. That's why I don't like to leave the session without questions. I hope somebody asks something.
From Dr. Mariam would like to ask
Yes, I have one question.
Yes. Yes.
For the first presentation, a comparative study on responsive facade system from Dr. Junior, I don't know, Professor Perry Madden. If she is here?
Yes, sure, I'm here. I'm listening.
Yes, I have a question. As we know, the movable type of facade is more expensive than a static or fixed one. So I want to know your opinion. If we, do you think if the initial cost can cover by the payback of the facade through the time, means through the more efficient result by the time, then fixed facade, more than fixed facade or a static facade means it can be cover the cost, initial cost, if through the time to be more efficient?
Thank you for your question. Actually, as we know, due to the constantly changing needs and the inadequacy to static systems cannot respond to requests as the changing request, the interest is increasing, and obviously they are a solution for many design parameters, but we should consider also the analysis. We cannot directly answer this question. I think we should consider the type of system, we should consider the environmental change and so on. That's why I think it depends on the analysis. We should consider all the parameters, and actually this is in the scope of our study it's a classification proposal. That's why we didn't analyze any changing environmental factors. That's why I cannot give any specific answer for it. As I told you before, it can be changed according to the environment and also the system. That's why we should conduct some analysis for it.
But you cannot guess how much successful can be to apply movable facade commonly, more than fixed facade. It will be successful, or what do you think about the success of this kind of facade?
For sure, it can be more expensive, but I think the success percentage is getting higher day by day, because we are using some simulation programs, more technology. That's why, according to the also material, I think the success is getting higher.
Thank you. Thank you so much.
Thank you.
Thank you.
Thank you, Dr. Mariam, for your question. Any other questions? I have one question then for Dr. Reham. Dr. Reham is there?
Yes, I'm here.
How are you, Doctor? I am very interested. I was very interested in your presentation. I want to ask you something apart from this presentation. I want to ask your opinion. Can biomimicry affect the aesthetic value in negative way? I hope you understand what I say, because mimicry is looking for the functionality, for sustainability, giving we cannot avoid the appraisal and the respect to this kind of facade. But how much can be beautiful? I mean the in another way, in the eye of beholders, how can be mimicry beautiful in the eye of beholder? Not professionals, I mean, just people.
Normal people.
Yes, because for sure architects will or professional engineers can evaluate the things more than others. But how can we avoid to negative evaluation of the people to this kind of designs?
Well, in my point of view, I think from my readings and research, I found that the facades or the building envelope, as I mentioned in the paper, it has a visual comfort. And this is one of the points that I stated in the matrix. It should have a visual comfort so that the rest of the people, normal people, can understand it or can digest this type of architecture. This is, I think, my point of view.
Yes, okay. You don't think we can do something very useful but not beautiful, for example, in the future, especially with this kind of simulation programs and parametric design, etc.?
Of course, usefulness is more important than to be visually nice. Function is more important than it to be visually nice. But if we consider both or make a balance between both issues, I think it will be much more better.
Thank you. Actually, I agree with you. Functionality itself, it's beauty.
Yes. It's more important.
Thank you very much.
My pleasure.
Thank you. I have another question for Seida. Seida, I didn't follow 100% your data input. Seida is here?
Yes, I hear you.
Yes. Regarding the thermal comfort evaluation in the facades, in the walls, I wonder if you used thermal transmittance constants and thermal damping in your data input to design builder. Did you do that? Because it is very important in a humid, moderated in the humid climates, like what the case study you select.
Yes, I use the transparency ratio and buildings form for different plans. So in order to compare energy loads of the buildings, cooling and total energy loss building.
And what about dumping? What about thermal dumping?
Sorry?
What about thermal dumping? Did you input thermal dumping in your data input?
No, I didn't add this value.
I think if you add that, maybe you will get much more accurate results. This is my opinion. You can discuss with your group and you can maybe try once to see how much is the difference.
Yes, thank you.
Thank you very much. Dr. Hurash, are you there, Dr. Hurash?
Yes, sorry, I was talking with
from our side. I want to express my gratitude to the group that they spent their time with us, and it was wonderful time. We spent discussing and listening to the different type of research, valuable research actually, and now the ground is yours.
Thank you,
Dr. Hurash, and thank you very much.
Thank you, dear Dr. Salar, our valuable session chairs. It was indeed a valuable 2 days of marathon in three parallel session at the same time. It was very indeed powerful without stopping since 9 in the morning till even it is already half 8. So even yesterday was a little bit more. So it was indeed a good quality of contribution from all of you. I really appreciate that. And even our rector sent his gratitude to you all. regarding the content of even the authors and contribution and the organization. We really appreciate all your support indeed. We will have our gala night. You are kindly invited to have, let's say, actually traditionally it's supposed to be gala dinner. I know that after the conference, the organizer is supposed to give you a dinner. So unfortunately,
Doctor, sorry for intervention. There is one question from Zainab to Dr. Riham.
Yes, of course.
Dr. Riham is there or not?
Yes, yes, I'm here.
Dr. Riham, Zainab is asking, regarding, do you have any idea about how apply the parametric design with the biomimetic approach?
Well, parametric design is not my field, so I really exactly don't know. Maybe there is a relation between the two, of course, due to the new programs of simulations and 3Ds and so on. But the parametric design is not really my field, but maybe it gives me another new idea for a new research in the next conference.
That's great. This is the goal from the conference.
Okay.
Thank you. Sorry for disturbance and the intervention, Dr. Horaksh, but we have
so
to.
In that case, I was writing that we thank all of the authors and session chairs, co-chairs, and contributors. You will always be in our hearts since now. Please keep in contact after the conference. If you have any question, of course, this conference idea, I believe that based on my experience during the last 5 years, that the conference is just somehow the starting point to start.
Yes.
You know that as an academician, the best possible place to increase your network is somehow the academic, such a kind of academic environment. So please, we are all academicians, so try to keep in contact with your colleagues in case if you see any topic or part or subject interesting. Try to find your network from different countries. So it will be a good memory of us. For example, I have gathered lots of our colleagues from these conferences, and I'm very happy with that. Even not only from my organization, with the time that we are going to other conferences, this is the best possible option for us as academicians to increase our network of collaboration. So please keep in contact with each other. Thank you for everyone for your great and valuable contribution. We will try to conclude, and I will send within 10 minutes, I will check the presenters, and I will try to publish your certificate of presentation and publication, presentation and contribution within 10 minutes for all of you, for sure. I will go to also finalize the other sessions as well. Please keep in contact and stay tuned, and see you soon in Gala Night within 20 minutes. Thank you for all of you.
Okay, thank you very much.
Work.
Thank you. See you soon. Bye-bye.
See you soon. Take care of yourself. Please keep in contact and stay tuned.
Bye-bye.
Bye-bye.
Nice to meet you all.
Thank you, dear Dr. Riham.
Thank you.
So you may, in any case, with this web platform, we will continue. I will try to come back within 20 minutes. So you may be around, or you may join within 20 minutes. It doesn't matter. Dr. Salar, thank you for everything, Dr. Mariam. And
thank you very much.
Valuable authors.
Thank you. Bye-bye.